Today's seminar will focus on two-way frequency tables, and the goals and I can statements for this lesson are: I can construct a two-way table, I can interpret a two-way table, I can find relative frequencies from a two-way table, and I can use relative frequency to interpret data and predict associations. So at this time, if you could please pause the video and copy this title as well as the goals into your notebook. Alright, then the foldable that we're using today is our two-way frequency tables foldable. And what we'll be looking at is interpreting two-way frequency tables. We're looking at completing two-way frequency tables. And we'll be looking at creating two-way frequency tables. So let's get started with what a two-way frequency table is and a few definitions that go along with that. Alright, so what is a two-way frequency table? So we have two different types of frequency tables. The first one is just a two-way frequency table, and this one looks at just totals of these different criteria that are met. So for instance, there's people who like cats or people that don't like cats, as well as dogs and no dogs. This is just how many times that these showed up when a group of people was surveyed. So 25 people, this was the number of occurrences that happened. Now a two-way relative frequency table deals with percentages and refers back to this two-way frequency table, and I'll show you a couple examples of what I mean here. So it deals with percentages or probabilities, like I said. So for instance, here it says 24, and this refers to 24%. So if we look at the number of people here, which is 6, and out of our total 25, if we do a fraction 6 over 25, so if I do that on my calculator here, if I do 6 divided by 25, we see that it's 24%. So remember, percent is out of 100, that's why this total is 100 here, and it's 24 out of 100. Now typically these might be written as percentages, so either with the percents in there or a 0.24, and the rest of these as 0.12, everything like that with the decimals in there. Then this would be 1, because everything here should add up to 1, or if it's written the way it is here, it adds up to 100. So all of these relative frequencies are based on these numbers over here. So if I did 6 out of 25, I got 24%. If I did 3 out of 25, I got 12%. And that total percentage adds up to 36, or like the 9 out of 25. So that's the difference between a two-way frequency table, where we're just looking at data that's collected, and then a two-way relative frequency table goes a little bit further and breaks it down into percentages, or how often these things are occurring. So that's a little bit of the difference between those two. A couple of definitions here that we should go over as well. So frequency, the number of times an event occurs, which I kind of just went over. A two-way table shows the frequency of data that is categorized two ways. As you can see here, it's cat, no cat going across the rows, and in the columns it's dog and no dog. So that's the two different ways that it's going. That's why it's called a two-way table. Next we have joint frequency. What this is found by dividing any number that is not in the column total or row total by the grand total. So we get these numbers from, and I'll highlight these in blue, your joint frequencies are the numbers that show up in the middle here. So are 6, 3, 5, and 11. You can think of it as a joint like in your arm, your elbow, that's in the middle of your arm, or your knee, that's in the middle of your leg. It's joint, so that's all in the middle. So these numbers divided by the total would be your joint frequencies. Same things over here. These are also joint frequencies, your numbers in the middle. And like I said, those would be divided by the total. So in this case 25, or since percentages here, that would be out of 100. Then we have our marginal frequencies, and that's the margins. So think about the outsides of a paper. and it is found by dividing any number that is in the column total or row total, so your outside numbers, your margins, by the grand total, which we had talked about is just this last box here. So we'll go ahead and highlight those marginal frequencies as well. And I'm just going to leave the totals blank because we would divide these out whether it's a joint frequency or a marginal frequency. So let's just go ahead and highlight those over there. And why don't we just highlight these as well so we know the distinction between the two. So that's a little bit of background behind frequency tables, how they work and the different components of them. So let's actually jump into interpreting a table here then. So let's go down to our first example here. It says, the data below shows the eye and hair color of students in Mr. Hopkins' third period civics class. Use the two-way table to answer the questions below. So as you can see, this is all completed here, ready for us to work with it, and we have some questions down here to answer. It says, is the table above a relative frequency table? Well, in this case, the answer is no. This is purely just numbers collected for students who have different eye color and hair color. If it was relative frequency, we would divide all of these numbers by the total in order to make it into percentages or probabilities. So this one is only a two-way frequency table. It's not a two-way relative frequency table because it's just pure data that was collected. Next, letter B says, how many students have brown hair? So we are going to look at brown, which is at the top here. Well, let's make sure. Oh, this is actually going to be going across because, we don't have red eyes or black eyes or blonde eyes. So it's across. And that total number would be 10. So we're going all the way across, adding these numbers up, looking at the total. So that total is 10. Next, how many students have green eyes? Well, now we're looking down a column of green, which is 3. Next, how many students have brown hair and brown eyes? So we're looking at a joint frequency here. So it says brown hair, brown eyes. We see that matches up here in this box that says 6. So that total is 6. And last but not least, we have a percentage we're going to calculate. So we have to figure out where we're pulling this from, whether it's a joint or marginal frequency. What percentage of students have blonde hair and blue eyes? So we know that this has to be out of 22 because there are 22 total students. It says what percentage of students here. So we're looking at the total number of students. So that's our denominator. And now we need to see how many students have blonde hair and blue eyes. Blonde hair, blue eyes would be 4. So this is a joint frequency. So we're taking a number that's in the middle of the data. So that's 4 out of 22. And we want to write this as a percentage. So we're going to divide that out, multiply by 100. And when we do that, so I'll get my calculator in here. Do 4 divided by 22. It gives us about 18%. Let's multiply by 100. We'll just round to the nearest whole number. So we'll say roughly 18% of the students in the class have blonde hair and blue eyes. So that's how we would interpret a table. Two-way frequency table here. Let's flip the page then and move on to completing. So this top one we'll do together. The bottom one I'll have you try on your own and check against my answers. So let's start with the top one here though. So it says the data below shows the enrollment of students in language classes at Citrus High. Complete the table. So what you need to do here when you're completing it, it's kind of like a puzzle. You're going to have to find the certain instances where you have enough numbers in order to find what's missing. So the first place that I'm going to start is going to be in Latin here. So I have 0, 4, a blank, 18, and 32. So if I add these up what I have and subtract from 32, I can just fill that in. So if I do 4 plus 18, it equals 22, and I do 32 minus 22, I get 10. So I know this number is 10. Now we're going across here in 11th grade. I see I can fill this in because there's only 1 point here. So let's go ahead and do that. I'd add up 12, 19, and 10 and subtract from 72, which gives me 41. So I do 72 minus 41. It gives me 31, so that I know that goes here. And as you go, this will start to fill in nicely. So now let's go down the German column. I'll add 14, 31, and 9. Using a calculator is okay here. I get 54. So 76 minus 54 is 22. Now I'll go across the 10th grade row here. 46 plus 22 plus 4. And I'm going to subtract that from 106. So 106 minus 72. That's 34. Now I can go down the French column here, which will give me, I'll add up here, 71 plus 34 plus 19, 124. So 137 minus 124 is 13. Now I can go across the 12th grade row here, do the same thing. 13 plus 9 plus 18. So I'll do 54 minus 40, which would be 14. And as you can see, this starts to fill in nicely. Do the same thing here in the Spanish column. 46 plus 12 plus 14, 72. 155 minus 72 is 83. And now we can get the total across here for 9th, which would be 83 plus 71 plus 14. And 0 doesn't matter, so 168. And just in order to make sure I have the correct numbers here, I'm going to add down this marginal column and see that that adds up. So if I do 168 plus 106 plus 72 plus 54, I get 400, as you can see, and that's what I need here in the grand total. So what I'd like you to do now is go ahead and pause the video and go ahead and fill this chart in, and then you can check against my answers when you are finished up. So go ahead and pause and try that out. Alright, then since you have filled it in, go ahead and check your numbers and they should come out to what I have in here. So in the 6th grade one, you should have had 68, 81. In the 7th grade row, you should have had 82, 55, 74. In the 8th grade one, 77 and 66. And then in the totals here, you had 185. And then I would have added all these up in order to check that they add to 1074. I did that, they do. So if you have all of these numbers in here correct, then you are ready to move on. If not, you should go back and review and figure out where you made your mistake. So that's completing tables. That's pretty straightforward, just doing some adding and subtracting there. Then let's move on to creating tables. Now these are a little bit trickier as they have a little bit more involvement with them. We have to use what's given to us in the examples here. They give us certain numbers, percentages, things like that. Example 4 you're going to try on your own. I'm going to do example 5 with you because it's a little bit trickier as it brings in a system of equations. So I'll work through that one with you. And here's what it says. At the honor roll party, students had the choice of cheese or pepperoni pizza and Coke or Sprite. Of the 125 students that made honor roll, so my alarms in my head are going off. I know that there's a total of 125 students, So I'm going to go ahead and fill that in right away. 125 is the number that I'm shooting for everything to add up to in here. So it says, of the 125 students that made honor roll, 64% had cheese pizza. So I'm going to multiply 125 by 0.64 to get 80. And that's going to have to go in the cheese pizza column because 64% of that total had cheese. So that's 80 kids out of the 125. Then it says there were 48 students that has cheese pizza and a Coke. So we have to figure out where that box is. Cheese pizza and a Coke. So that would be here. That's 48. Okay, and then it says 5 more students chose to have a Coke rather than a Sprite. So we're going to come back to that part as that's a little bit trickier here, but we can start to fill in certain parts of this chart as well. We can fill in this box and this box, but then we'll have to set up a system of equations to get the rest. 48 and 80, this is going to be similar to doing your completing here. So 80 minus 48 is 32. And now we can get this total as well, the total between cheese and pepperoni. So 125 minus 80. We know that 45 kids had pepperoni. And now we're kind of left here with information that we have to figure out. We could do some guess and check, and 5 more students chose to have a Coke rather than a Sprite, but let's not do that. Let's actually set up an equation here. So we know that Coke plus Sprite should equal 125 students. We also know that 5 more students chose to have a Coke rather than a Sprite. So Sprite plus 5 more is equivalent to Coke. Now it's a simple substitution problem, which we've done in the past. So I'm going to put S plus 5 in for C in this case. So I'm going to have S plus 5 plus S equals 125. Combine like terms, we have the two S's, so 2S plus 5 equals 125. Let's subtract the 5 here. That's going to give me 2S equals 120. If I divide by 2, S is 60. So we know that 60 kids had a Sprite. Now we can plug this 60 back in for S in this equation. So 60 plus 5 equals C, which is 65. So we know that 65 kids had Coke. Now based on the 60, we could have figured out that 65 instead of substituting it in here, but just wanted to show you that it works. So now since we have these numbers, we can figure out the rest for pepperoni here. So that's going to be just like completing, like I said before. So 65 minus 48 is 17. And then 60 minus 32 across this row here should give us this other one here. And that is 28. And it also wouldn't hurt to check to make sure that all these numbers add up and work out when you're doing these. So this one was just a little bit trickier, like I said. We had to use a little bit of an equation to figure out the rest of this one here. But after looking at that one, I would like you to try example 4 here. So let's read the example together and then you can get started. So at lunch, the entire 8th grade class of 320 students were surveyed to see if they were left or right-handed. Only 36 students were left-handed. Exactly 45% of the 8th grade class are boys, 127 of which are right-handed. So using this information, pull it apart one piece at a time. You want to fill in this chart. And once you're done with that, I will show you the answers that I have. And you can compare and see if you are on the right track or if you have to go back and try it out again. So go ahead, pause the video here and try this one out. Alright, you should have tried that one. So what I would like you to do then is compare your chart to mine. So based on the numbers here, I had 17 left for boys and 127 for right, which total 144. Girls 19, boys 157, or I'm sorry, girls 157 for right-handed, total 176. And then just the total number of left-handed, total number of right-handed, and just your marginal totals as well, up for 320. So if you had trouble with this one, try it again. If you're still struggling with it, flag me down and I will help you figure out where your mistakes are and how I can get you onto the right track. Other than that, that's our seminar on two-way frequency tables. And let's just review our goals for the day as well. So again, we did two-way frequency tables, and our goals or I can statements were: I can construct a two-way table, I can interpret a two-way table, I can find relative frequencies from a two-way table, and I can use relative frequency to interpret data and predict associations, which we did all of those things within your foldable today. Again, as always, if you're still struggling with this, go ahead and watch the video again, or you can ask me questions.